Hello, in this video we're going to go over the examples on page 5 and 6 of your guided examples for hypothesis testing packet. These are both hypothesis testing for proportion examples. Now I recommend that you try these on your own first and then check your answers here or on Blackboard. But this video is here for people who are struggling or feel like they need help on these problems still. Our first example on page 5 reads, in testing a method for gender selection, 20 randomly selected couples are treated with a method, and 18 of the babies are girls. Using a 0.05 significance level to test the claim that with this method, the probability of a baby being a girl is greater than 0.75. Our first step that we need to complete is a requirement check. The first requirement is random selection, and we can say that the couples are randomly selected. The next requirement is that there's a fixed number of independent trials with two categories. The two categories would be that the babies could be a boy or a girl. The next requirement we need to check is that NP is greater than or equal to 5 and NQ is greater than or equal to 5 are both satisfied with N is 20 because there were 20 randomly selected couples. So 20 times P, which is 0.75, is equal to 15. That's in fact greater than 5. Now we know NQ would be 20 times 0.25. Well, that's 5. That is equal to 5. And that works because we had a greater than or equal to sign. We need to test the claim that with this method, the probability of a baby being a girl is greater than 0.75. So our claim is P is greater than 0.75. For our hypotheses, our null hypothesis always has an equal to sign. So we have our null hypothesis is P equals 0.75. Now our claim does not include equality because there's no equal to, greater than, or equal to, or less than, or equal to sign in our claim. So that means we can just use the same statement, P is greater than 0.75, as our alternative hypothesis. The desired significance level given to us in this problem is 0.05. Now let's take out our calculator. Your calculator, go to Stat, over to Tests, and we're going to select option 5, which is our one prop z-test. And for this problem, we need greater than 0.75 was our P. So P equals 0.75. Our X was 18 because there were 18 out of 20 that were baby girls. And N was 20. And because we had a greater than sign in our alternative hypothesis, we want to use a greater than sign here. And then we're going to go over to, you can press calculate or draw. I usually prefer to choose draw. And I have a right-tailed test. My p-value is 0.0607, and our z-value, our test statistic, is 1.5492. As you can see, I've recorded the information we got from our calculator. We have a right-tailed test. Now, our significance level was 0.05, and the associated critical value with that is 1.645. We can shade this value here. Using my critical value method for a right-tailed test, I can see that 1.5492 is not as extreme as 1.645. It's in the fail to reject region. So 1.5492 is less than 1.645, and it's in the fail to reject region, which is anything before the purple shading. Using my p-value method, I'm going to compare my p-value with alpha, which is 0.05. So my p-value is 0.0607, and that is greater than. And if p is high, null will fly. So we fail to reject. Visually, you can see that the 0.0607 does not fit within the value of our alpha, that area, 0.05. So we only reject if this p-value is smaller than the 0.05, meaning it fits inside that region. So we can see here clearly that we're failing to reject. Now, I showed you the critical value method and the p-value method. You, unless otherwise stated, you may choose one or the other. You don't need to do both. I think it's important to understand how both work, but I know that students usually choose one method or the other, and most actually choose the p-value method, though you're free to choose either. Now let's determine our conclusion statement. Now, our claim was that p was greater than 0.75, so our claim did not include equality. And we did fail to reject. So we can say there's not sufficient evidence, sample evidence, to support our claim. In conclusion, we can say there is not sufficient sample evidence to support the claim that using this method, the probability of a baby being a girl is more than 75%. Let's look at our sleepwalking example. A study of sleepwalking or nocturnal wandering was described in Neurology magazine, and it included information that 29.2 of 19,136 American adults have sleepwalked. Would a reporter be justified in saying fewer than 30% of American adults sleepwalked? Use a 0.05 significance level. First, we need to do a requirement check. The sample is a simple random sample, and there's a fixed number, 19,136, of independent trials with two categories. You either sleepwalk or you don't. Now, the requirement that NP is greater than or equal to 5 and NQ is greater than or equal to 5 are both satisfied. You get N times P is 5,740.8, which is certainly greater than 5. And we get N times Q is 13,395.2, which is also greater than or equal to 5. So all three requirements are satisfied, therefore we can move on with this problem. First, our claim is that fewer than 30% of American adults sleepwalk. So that means we would be saying P is less than 0.3. This claim does not include equality. For our null hypothesis, we'll say that P equals 0.3. Now, for our alternative, we can simply use the same as the claim, since the claim didn't include equality. P is less than 0.3. The given significance level is alpha equals 0.05. Now, there's an issue with this one that we have to get around before we can move any further. We're not given a value of X successes. We're just given a percentage of sleepwalkers in this problem. So we're given 29.2 out of the 19,136 sample had sleepwalked. So what we need to do is we need to find our value of X. And in order to do that, we're going to take our 19,136 and we're going to multiply it by 29.2%, which is the same as 0.292. Remember, we don't use percentages in calculations, we change them to decimals. So go ahead and multiply. We get 5587.7. We could only use integer values, so that rounds to 5,588. Now we can go ahead and find our test statistic and our p-value using our calculator. Click Stat, go over to Tests, and enter item 5 as one prop Z test. Our p-value in this problem is 0.3. We just calculated X to be 5,588. Sample size N is 19,136. And our alternative hypothesis that we used was less than. So we can go ahead and press draw or calculate, How about we press calculate this time because we haven't done that yet. And we get our test statistic as z is negative 2.410 and our p-value is 0.008 rounded to 3 decimal places. I've written the information that we found in our calculator. It's important to make sure that you are labeling z equals and p-value is rather than just writing the numbers, because we're going to actually do some hypothesis testing that doesn't have a z statistic but rather a t statistic. So you need to show that you know the difference. Now, we could have got the diagram from our calculator, but we pressed calculate instead and we can just figure it out on our own. We had a less than sign, so we're going to have a left tail test, and our z-score that we came up with goes with that, negative 2.410, and we'll shade to the left of that. And our shading represents the value of 0.008 being shaded. Now, our alpha for this problem is 0.05. So I'm going to shade a region here. This is not to scale. And this region, this whole shaded region is 0.05. My critical value associated with the left-tailed test with an alpha equals 0.05 is negative 1.645. And I got that from page 2 of this very document. Now we can choose to reject or fail to reject our null hypothesis. I'll show you using critical value method and using the p-value method, but remember, you don't have to do both. You can choose one or the other. I'm showing you both for learning purposes. So our critical value or CV method, what we're doing is we're comparing our test statistic to where our critical value is. Now, our critical value is at negative 1.645, and it's a left tail test, so anything that is after that value is in our reject region. We have our unshaded region is the fail to reject. So anything more extreme than the number negative 1.645, we're going to reject. And negative 2.410 is less than negative 1.645. Since this is a left-tailed test, that tells us we're going to reject the null hypothesis. Now, using our p-value method, we compare our p-value to alpha, which is 0.05 in this problem. And our p-value is 0.008, which is less than alpha. If p is low, the null must go. So we reject our null hypothesis. Let's determine our conclusion. Our original claim did not include equality. It was p is less than 0.3. We did reject our null hypothesis. So our conclusion is going to take the form of the sample data support the claim. In conclusion, we can say the sample data support the claim that fewer than 30% of American adults sleepwalked. You're now ready to move on to the next video where you'll do hypothesis testing for a mean with sigma known.